Hi everyone. My name is Shirish Bhardwaj and I am working with AEEE. I'll just give you a very brief background of today's webinar and the decarbonization charter that we say and we are working on it. This is Decarb December is a sort of learning series on the thought to action in decarbonization. And decarbonization business charter was conceived to establish a unified platform that brings together key stakeholders and fosters collaboration among various decarbonization construction sector stakeholders. So the initiative is a collective effort between WRI India, AEEE, Mahindra Life Spaces, and EcoCollab, and which aims to address the shared challenges and opportunities in the space. The Charter provides a framework to identify and prioritize critical actions, steering efforts towards the common goal of reducing carbon emissions in the sector. So over the past few days, I mean, we have been doing this webinar. So we have our first week where we are doing. So two sessions have already happened, and this is the third session for the week. And the webinar series are designed to provide practical insights and strategies for decarbonizing our building sector, so that we can have a more sustainable future. And I mean, the industry players, the participants can learn from this. So with for no further ado, I think I'll start with our speaker's introduction. So our today's speaker is um uh, hello. Am I audible? Monish, are you there? Yeah.
Yeah, you're audible. Yes.
Okay, so our today's speaker is Monish, and Monish is a alumni of SPA Delhi and IAAC Spain. He has studied from there, and he's also a founder and principal architect of Ant Studio. His studio has received international recognition for their work on nature-inspired biophilic passive cooling building envelopes. They are nature-based low carbon air cooling solutions called Coolant won a Asia Pacific Low Carbon Footprint Challenge and was funded by UNEP. Manish is also a TEDx speaker and has also presented his work at various national and international forums, including G20 Summit at Bali and at various other international forums. And he was also a keynote speaker at World Environment Day in New Delhi in 2018. And he's also a visiting faculty at SPA Delhi. And I think this is a vast experience he has, and he has also exhibited his work at various platforms at IITs and IIMs, etc. in the country. So I think with that much of experience, I think it will be a very great honor to have you with us and to learn from you. And I think Monish, so I'll hand it over to you to speak on our today's topic on chill the smart way, smart cooling techniques for buildings in India. So I'll request everybody to please mute themselves if they are not speaking. Tinu, can we do it from our end? Yeah. Yeah. So our today's topic is chill the smart way, sustainable cooling techniques for buildings in India. So I'll hand it over to Monish now. Monish, please take the floor and yeah.
Yeah,
Thanks.
very good afternoon to everyone. Thank you, Shirish, for the warm introduction. And today I'll be talking about the work that we guys are doing in this domain, especially focusing on building envelopes and how we can use them to reduce air conditioning load. So I'll be talking, I'll just share my screen. So I have a couple of presentations to share. One will be focusing generic on the work that we are doing and what is the background and inspiration and all that. So I also have a couple of other projects that wherein we have done detailed, certain one project is the simulations to understand how it behaves. And one is a project that we have implemented recently and started collecting data. So I would request all the guests to actually ask, to keep it very interactive and ask, please stop me whenever possible. It's, during the presentation to ask. It'll really help us also to dive deep into the topic. And yeah, and please ask a lot of questions so that it'll also help us in our research altogether. So coolant is what we call this. Like we are a practice that are trying to work at the intersection of these three: art, nature, and technology. And most of the work that we are trying to do is to see how we can bring in nature-inspired solutions into the built environment or the this one. So this we are doing it at different domains. I mean, whether it is art installations or architecture, and also the product level, what we call as coolant, and to see how we can try and mimic nature as much as possible through our work. And one thing that really strikes me, both as an individual and also as a practitioner, is that when we talk about nature, the first thing is that we uh, take inspiration purely from the form and the shape of a certain thing that we observe, which is the first one. And that did inspire us in different ways in the work. But the second thing is about the process, wherein we are trying to see how nature mimics. We are able to learn from that. I think this is something that we are investigating quite a lot at Coolant to see the process of cooling, or how, for instance, the shading and stuff that we can adapt it into the build that is there. The third is again ongoing research mimicking an ecosystem, wherein we are talking about the natural growth in let's say moss or anything that cultivates naturally on when you leave nature. I'll also be talking about that as well, and trying to see holistically combined together how it helps in the performance of the buildings. And so the topic that we are discussing today is, I think, which we are all, I think, pretty much everybody in this is familiar with how the air conditioning is, contributing to global warming. It's a vicious circle. I mean, the paradox is that while we're trying to cool our spaces, we end up heating the surrounding environment, and so on and so forth. But one thing that definitely strikes all of us is our cities are definitely much hotter than the suburban and the forest areas and all that, and wherein that's because the amount of heat that is reflected from the surface of the buildings, or the all the activities in at a city level, not pointing out to any one particular one. But then for me, I think this particular section, what we look at it is quite interesting in a way for a research, is that the cities, while I think they're hot for various reasons, our forests, and whenever we go to anything with nature based, there's a drastic drop in temperature. Like there is an instant drop in temperature that we notice. Now that is something that is some very relevant to the work that we are trying to do, and see if we can mimic that into the built environment. So having said that, I'll move forward, and we will discuss that more in the next few slides. So, I mean, off late, I think even now with the COP 28 that's happening, we have been hearing a lot about the impacts of air conditioners and how many air conditioners we as a nation, the growing nation, will be needing by 2050. And these numbers are quite uh, extremely, what do you say, scary and threatening at the same time, because as per stats, I mean, it says that we'll be needing 1 billion air conditioners, new air conditioners, just in India, and which is equivalent to, the amount of emissions that will be coming out of this if we as a nation, if we are going forward. I think it's pretty scary. So one straightforward answer that comes to me as an individual is that, no matter whatever we do, air conditioners is not something that honestly something that we can probably get away with. It is something that we have as a solution that we have been using for quite some time now. And the only way that probably if we can try and make an impact is only by seeing how we can reduce the consumption of air conditioners, but not to replace it. At least that's not the agenda behind the work. And to see, I mean, as a practice, we are seeing the two things that we are trying to do. One is that what if we like look at this building envelopes as a product, and see how more and more people can actually start using climate responsive building facades, is one of the things that we are focusing on. To especially, like if you look at, like I said, every year 15% more and more households are able to afford air conditioners. That's something that, and the affordability as a nation in India, more and more people are able to, as a growing economy, are able to afford air conditioners, and that is also putting a lot of like the demand is growing drastically. And but coming from architecture and whatever we guys are trying to do, is that the answer that for me is pretty obvious, but that is not how it works in the real world, is that climate responsive buildings or architecture is the best way to cut down on the consumption, or like so that when buildings start responding to the local environment, no matter wherever the buildings are there, that will straight away reduce the impact or the demand on the air conditioners, because that's how it should be in an ideal scenario, wherein straightforward we can say that the demand or the dependency on air conditioners can actually get down. So the question here is that while that seems like a very straightforward or a most obvious answer, but the struggle or the question is, how do we make people cater to this? Because that's not something that, like, people are doing, thinking that, because it seems like the most obvious answer, but that's not how it's working in the real world. More and more people are actually, when they're building, the general tendency is that we'll build the way we want to, and air conditioners will take care of the cooling load. That is a probably the mindset with which things are moving ahead. And I also would like to utilize this platform because with decarbonization, I think a lot of very strong, opinionated, and I mean, organizations are coming together. And even our city planning and the way I mean, like when you're talking about the way the urban planning is done, like especially in areas, there is not much emphasis that is laid on natural ventilation, how the buildings will actually get naturally ventilated, or shading, or basic simple principles like that, which can further reduce the air conditioning just with the help of planning, and our cities better, and wherein we can make sure that buildings are actually properly ventilated and so on and so forth, to reduce this consumption. So if, like, no matter, I mean, while there are a lot of initiatives that we have seen in the past, like the cooling action plan, or like, India's commitment to by 2030 to reduce this the air conditioners and so on. But I'm not really sure. I mean, maybe I'm not aware of that. I'm not really sure how that is translated at the city level or into the planning, wherein like if you can push this at the building level to make sure that how can we make more, I mean, all the new buildings that are coming here to be climate responsive. That's a question I want to discuss if somebody is would like to talk about it or comment on that and debate. But now coming to the coolant, what we guys are trying to do is like look at some of the systems that have worked in the past and see how we can rethink and readapt them in today's date. Like, how do we try to bring it into this one is the work that is what we are trying to do here. So this is while when we started off with this particular ideas and installation few many years back. Earthen pots are traditionally used for drinking water, and the water inside the earthen pots naturally remain cool. So we thought, what if we use the same technique, but instead of trying to cool water, we use it to cool air. That was the idea behind where we started off from. And in the process, we found some really exciting and interesting references from the past, wherein the slaves used to fan the surface of the pots for cooling back in Egypt. So, I mean, the slaves used to stack the earthen pots filled with water and fan the surface of this. And so it's something that we came across very interesting, which we thought we used it as a very, what do you say, inspiration behind the first project what we did that like put us on this research line what we are following right now. So this was a factory where what you see on the screen is that this is a plan of a factory, and there's another factory here. So the in-between space between the two factories used to get extremely heated up with this. On the bottom right, there is a DG set, diesel generator, that used to throw a lot of hot air into the environment. This one, what you see over there. And in peak summers, when the ambient temperatures exterior are beyond 45 degrees, the local temperatures here would like peak up beyond 50 to 53, and it was unbearable for like anybody to stand. I have seen actually literally people running from one block to another to escape the heat that was thrown from this machine. So what you see on the left was the a proof of concept that we built, wherein we made a brick lattice and poured water on that like a jolly, and see how, like, adding this cuts off the heat that is coming from the machine and then cools it. And the idea behind this is that if anything that we make it like a wall in front of it to block it, the air would bounce back to the machine, and then it will reduce the cool efficiency of the diesel generator itself. So the idea is to not to block the air that was coming, but rather channelize it through a device that can help in cutting down the heat. That was where we started from. And to do that, like, what we came up with is the beehive, which was earthen pots made by potters and very easy to make, produce. We had done some base analysis with the help of a friend who was who just help me configure what is the right direction. I mean, the size, the length of the pot should be, so that we can try and achieve certain performance and so on. So we designed it like a beehive, so we're able to get the surface area of the pots both inside and outside and stack them easily on the top. And we saw some notable, I mean, substantial drop in the temperature, so which led to what we are doing right now. But one question that, that struck me after this is that once we put this out, we often used to get questions like whether this can be done inside a living room, or can people put it in their houses or stuff like that. And so everything else what we are doing right now is then an attempt towards answering that question as to how we can uh, take this product what we did for an outdoor space into an indoor space. So yeah, this is some of the initial studies that we have conducted to understand the performance, I mean, the geometry of the pots and so on and so forth. So, moving ahead, um, what I realize is that both as an individual, like, and also studio, what we're trying to do is, can we take this installation, what we had done as a one-odd installation in a factory, into buildings, and if to do that, and how we have to modify this design or the configuration and so on and so forth. So we started looking at some of the I mean, traditionally there are like India has absolutely a ton, I mean, many examples of buildings that have used passive design as a means to keep the spaces cool and so on and so forth. And so what we were looking at is that, can we learn from that and then design building envelopes and facades? Because in today's date, the problem or the challenge that like I said earlier, I see is that people do not have the time or the inclination to research and learn and actually put it out there. I mean, people are just like, okay, I'm able to buy off the shelf an air conditioner 1.5 ton or 2 ton, and that helps me keep this cooling. I'll do that rather than thinking about how we can actually make it more naturally ventilated or use passive means to reduce. So people do not have in general that kind of a mindset or the time or the bandwidth, to the extent that people are very cynical about asking whether natural systems even work, or to what extent these there is also this cynicism that we definitely face, is that to what extent these passive buildings or anything, I mean, I'm not just talking about building envelopes in general, that do the work or stuff like that. They don't have the time. So the whole idea is that, can we make them into products so that people can actually, like the climate response facades or envelopes which we are focusing on, that can they just get it within, they don't have to put their head into it. Somehow we put all the head and all the research and we can get it. That was where we thought we can move forward with the work. And so in doing that, like I said, I mean, we studied a lot of examples which we also used to tell people that how some of the beautiful jalis and everything that have worked in the past, and some of the beautiful examples of this, how these simple systems like Venetian blinds, or this what you see on the extreme right is this beautiful diagram that I came across, wherein the river reeds are actually used in the beginning as actually for blinds, which led to the Venetian blinds. So, and something that I think most of us probably are familiar with, mashrabiyas, wherein the wooden lattices, which also forms a strong architectural vocabulary, are used to keep both the spaces also cool, and also they are social spaces that are also have more than actually just cooling, also like in spaces for the women of the in the Middle East to actually sit and look at the street and so on and so forth. So this is an example, this is a nice example where there's a wooden lattice in Mashrabiya where there's an earthen pot fit inside. And as the air brushes through this earthen pot filled with water, they would get cool air inside. And this was both used for cooling and also drinking purposes, this earthen pot that is there. And the cross section of the envelope is such that the hot air from it escapes outside. And so since we are, I mean, so in our particular case, we wanted to, like, rather than why a single earthen pot, what is the right, how many pots do we need to actually get to the right kind of cooling load, what we talk about in this, is some of the questions that we are asking through our work. And even in India, we have some beautiful examples of jarokas and other stuff, which were actually designed to, and also with this stone lattice or the jali, was designed to keep the environment and everything locally cool. But that's not like what is done right now, right? I mean, so we thought we will take the beehive and try and experiment it with. We have tried it in an indoor space, in an atrium, and certain other spaces where in a public space. This was for a science festival. We had made like a demo wherein people were we had installed it that like to demonstrate how the cooling and everything works as an art installation. So with these earthen pots with trickling water on top of that to show how simple systems like this could also work. And in other areas where, like I said, I mean, we are trying to combine it with technology and see if we can optimize the system better with the help of CFD and all that to see if we can probably optimize the geometry and other places to extract even better results. And next. So yeah, in short, it's a very simple evaporative cooler wherein we have earthen pots and with a geometry wherein we are trickling the water on top of this. Earth retains the water because of this with the porosity, so we don't have to constantly keep pouring water. And as the air brushes through it and comes inside, it naturally cools. It's a very simple system. Um, and but the idea is also that in such a simple system, we can also use in one of the latest works that we have done. We have used timers and to regulate the amount of water that we are flowing. Like instead of pouring the water constantly, the idea is that we can actually use timers and sensors to pour the water only when it is required. So we wanted to take the system from indoor spaces like what I had shown you, like atriums and other spaces, what we had done, to building envelopes and to see how we can adapt it on building envelopes and what is the right way to do it. So this has been our focus and to see what is the right adequate component, because we do come across these questions from a lot of people asking, can we put it on a window or like a window AC or a 2x2 or a 3x2? Is it sufficient for us to cool? Or questions like, can we, how big it should be? So similar to wall window ratio, is there a wall cooling ratio or something wherein you have a system that is what's the right ratio that is good for, like these are some of the questions that we are still answering, that we are also not fully there yet, wherein we can say that on a particular wall what is the right proportion of this that is there, while we are still working on it. But I think these are some of the questions that we face and we are working towards that, like but what I'm showing you right now is that these are some of the works that we have done in different places, trying to see if we can like instead of regular facades or envelopes, we can propose something like this. And in the process also, like this what I'm showing you right now is a factory space wherein we have provided multiple of these units, windows, and we try to evaluate how the cooling will be on a window unit where you have this evaporative cooler with made of terracotta, and then how does it reduce the temperature inside in a shop floor. And so yeah, coming back to, so that's where we started. But then we realized that there are certain challenges that are there with just using cone as the geometry when we want to scale it onto multiple levels or multi-storied buildings. These being not fully like fixed on a grill, or even or otherwise we have to do it like a wall, wherein like a civil masonry wall made of this terracotta. That's possible. Like so how do we how do we scale it? That's one of the questions that we kept asking ourselves. And how do we take it to different places and try to make this climate responsive based on different locations and so on, India being a diverse country with a lot of these different climatic zones. So we wanted to check if we have to adapt this in different areas or different locations in the country, how do we do it? And so that's where it came, like what if these systems that we're talking about, something like this, what if they could breathe, and what if these the buildings can have like a second skin, just like the clothes that we wear according to seasons. So ideally, this is how it should be. That's what we kept telling ourselves, that if we have to relook at the buildings. And are there any questions? Is someone saying something? Hello, hello. Yeah.
I think, yeah, we are good to go now. Yeah, please carry on.
So these are some of the questions that have been asking ourselves, how buildings should behave. And ideally, a very good reference, or for me personally, is that like in winters right now, I'm wearing a jacket, and and that keeps us like naturally warm, and wherein that's absolutely opposite. In summers we wear light clothes which are very airy to bring the breeze in and get the and you know and take the cool air inside. And there is no other way why, I mean, there's no reason why buildings should not be like that according to different seasons, and you should do that wherein we can make it more airy and so on. So, and another thing is like this is a beautiful example, I think, which probably is what we are trying to actually replicate in most of the work, is that the moment we walk under a tree, there is a drastic drop in temperature. And there's a substantial drop in temperature the moment you walk, even on a peak summer day. And that's primarily because of the evapotranspiration that happens from the ground and also from the leaves on the top. Both it provides both shading and also cooling in the process. So the question is also that, can building envelopes behave the same way where the water is contained inside? So instead of building materials that reflect heat back into the atmosphere, like the way that they do right now with glass and other materials that are there which reflect the heat back into the atmosphere, what if they absorb the heat and behave the same way, learn from the trees, and we use evapotranspiration as the medium for cooling both the surrounding environment and also the inside spaces. So this is what I think that like really struck with us. And also the first slide that I was talking about, the urban heat islands. Like, if I mean, ideally, if every building behaves like this, instead of reflecting the heat back, it absorbs and creates this kind of a process, our cities will be much cooler. And and overall they can also help in instead of trying to like emit emissions into the atmosphere, probably we will be emitting oxygen and evaporating water into the atmosphere, makes it even much more livable as cities. And I mean, as both as a space and also like it can also help in the cycle, because seasons is one of the bigger thing that we talk about when we talk about trees, and how these trees contribute to the making keeping the seasonal changes and everything in order. But with more and more urbanization, what we are seeing is that this order is also being destroyed because we are losing a lot of trees due to deforestation. So if building starts behaving like trees, probably that's also an opportunity for us to restore, if not holistically, but a certain balance in the in the environment. And that is a thought that we think, I mean, ideally, if we do that, that will be great. So taking inspiration from here, we came up with this new idea, or the new formation of the instead of the beehive, the aerofoils. So these are what you see on the right is the geometry of the aerofoil, wherein the water is contained within this. So these modules actually can work as a shading device. So one can set the angle according to the solar radiation. The spacing can be adjusted to optimize the daylighting and the angle and everything. And as the air passes through this, it acts very similar like an earthen pot. Since the water is inside, the water escapes from the surface of this, and as the air brushes and comes inside, it becomes naturally cool. That was the idea. So that how we can mimic the leaf in the system and then see this. So this can be plugged into any. It's a very simple system that can be plugged into both old buildings and also new on existing windows like this. So we can, like I said, we can adjust the spacing. The water runs through the system instead of so it's kind of a direct indirect evaporator cooler, wherein the water is evaporating from the surface of it, but not we are not pouring the water like a direct evaporator cooler like in the beehive continuously on the top. So the water remains within the system. And uh, like this is an indicative illustration that shows how we can adjust it according to different angles. They need not be kinetic, wherein some clients do, who are okay with the budget and all, like they would want to make it kinetic. But most of the cases that we are working on, we make this as a static setup optimized for a particular daylighting angle, sun angle, and so on, according to the location and stuff. So yeah, so these are some of the projects that we are doing right now in different locations, where we have taken this idea and we are designing this facade to the particular sun angle of the location, and uh, according to the space and so on and so forth, wherein we are able to cut the direct heat radiation into the building and also help in what do you say cooling and so on and so forth. So there's some of the examples which we have implemented. This is in our own studio. The first one that we did as a mock-up, and we had seen actually a straightforward solution here, because it was impossible for us to sit without this on a summer day, because this is facing west, in fact southwest. So like this table, what you see inside, people, I had seen an example where all of these guys sitting on there's a small table that you see, would be sitting in this opposite corner when there is no radiation. And so all of them, like, would be sitting because of the amount of the sun and everything that we were getting in. And by installing this, there was a direct drastic drop in both the temperature and also the direct glare and everything that we're getting inside, and made it quite uh, I mean, definitely made the straightforward the space much more you can say workable, or bearable rather. So that's one of the systems, and I can talk more about it if you have any questions before I move forward. Any questions so far?
Sir, I'm Deepak here.
Yeah.
I have a doubt. Like, how do you control water flow rate in this, sir?
In this, we are actually so there is a system in where we are pouring the water within this, and the water remains inside. Just that when it is humid or something, we just don't let the water from the source to come in. We just let it be, and whatever water, it's a very thin capsule that is inside. It evaporates directly, and it lets it be. That's it. That's the idea behind this setup.
Thank you. Thank you.
Yeah, we have one more setup which we call as the binary. I'm also going to discuss that, and we found some really interesting observations there as well. So while this is the second, we have a third setup as well. And if you have any questions on this, I can take. Otherwise, I'll take collectively questions at the end as well. Yeah. So another observation from the work is this bioreceptivity. With terracotta, one beautiful thing is that when water and terracotta they come together over a substantial period of time, there is this moss that grows on the surface of it. And people typically confuse moss with fungus. And while I think that's some question that a lot of people ask me, what happens to the dampness that people typically face it in the like inside, within a space on the walls, that when the fungus that kind of forms with this dampness with the paint, when it mixes the chemical, it's very toxic. But whereas this is not the case on the exterior, this natural growth that forms on it, it's kind of beautiful. There is a way to easily control this just by adding a few salts to the water at the source. We have seen that it's very easy to control the growth of this. Actually, it's not difficult to control this, but what the studies say is that it's in fact this moss is a very good thing for air quality, and we can, if amplified, this can actually help in even both I mean, as a natural medium for evapotranspiration and also enhancing the air quality, which is good. So there are, in certain areas we are actually wanting to grow this, because instead of trying to kill it for many for a couple 3 years, in our first project that we did, the clients would add chlorine in the water to make sure that there is no kind of growth on the surface, and the tiles would look absolutely new as ever. But but later works, we also started seeing that, instead of doing that, let us try and cultivate this or amplify the growth of this to see what can actually come out of it. So, like, taking this as an inspiration, we are also working on something. We came up with this another idea called the binary, and so this we have done in a few places, and we are getting some really good results with this also. This was an idea where we are using this vertical, this tiles, terracotta tiles, to trickle the water down, and then we have inserted these earthen pots as plants, so that the this can help in growing the plants. And over a prolonged duration, this can actually, we wanted this to be a combination of a vertical green, vertical garden, and a cooler or an air cooling facade at the same time. So that in a way it also behaves like a zero plastic vertical garden also on the building envelopes. And we can play with the amount of pixels and this and that in this, and see how, like, at an eye level we can have this pixelated, so that more and more we can get better view and accessibility outside. And in the rest of the areas, the density can be more for better cooling, and so on and so forth. So we have tried this, and we're getting some really nice results with this also. This is something that we have done in our office space. And so, but this we are doing also as a third alternative in a few places, and we're getting some really, like I said, good feedback on that. So these are some other installations where we are testing this to see if we can use terracotta to as a cooling tower, as a 360 cooling tower. And recently we're also testing it to see if we can use it for pre-cooling in cooling towers, so that when the air is already pre-cooled before it enters into the cooling tower, so that reducing the load on the cooling towers as well. That is something that we are we started experimenting and exploring recently. We have done it in a couple of places, and we'll see how that goes. So the idea is that if somehow these kind of systems, which are extremely robust and low cost, can help in reducing the cooling load on the cooling tower. So we have done it in a mall. Pranjal, if you can pull out the video of that, we can also show that, like, that particular video that explains about how it works. So to, yeah, I'm to seeing wherever we can do it, not if not directly on the building envelopes. So we're also checking if how this can be retrofitted into any of the cooling towers as a for pre-cooling. So I think that's more or less about the work, and some other art installations that we're doing as a cacti. This one to see if in the shape of a cacti, there's installation that can, like in especially in public spaces, and we are doing one in the airport, where in the airport we can use the similar kind of a system for. There's a presentation that we made for that project, so I'll just run it through that only. So cacti, because cacti is extremely resilient in nature, we thought that's a beautiful form to take inspiration from. And with less water and everything, we can help in, like with the help of terracotta on a system for cooling. So in a way, the idea is also that with art, we can talk about natural systems and create awareness among people, was the idea behind this work. So yeah, some other works on similar lines. We're combining art and the schooling together in atriums and public spaces to talk about how this natural systems can work. This was designed for a large atrium in a building. Yeah. So that's, I think, about the overall presentation. I have a detailed one project where I can go in detail, but before that, I would like to check if you have any questions. I can actually take those.
This consumes a lot of space, no, sir? If there is a space constraint, then we cannot go for your system, no, sir? What you are designing and what you are operating. Which one?
No, no, no. Definitely, we are doing it on building envelopes. It takes a space of the width of the envelope. I mean, the system that we're doing is 230 millimeters, and with another 200 millimeters gap. So total on the front elevation, with a gap of whatever that is viable over there. So the width of the building envelope is roughly about 230 to 250 millimeters. Okay, on the building envelope. This cooling, what I'd shown you towards the end, it's more of an art installation, depends, it's scalable, depends on space to space. There is no such thing as, it is entirely dependent on which project. I mean, we are doing this for public spaces or like areas for outdoor cooling, you can say, like near monuments or installations, but not necessarily inside the living rooms or stuff like that. That's not the idea. Yes.
Actually, this is not possible in because of in cities we are spaces are very costly, no, sir. So we cannot experiment inside these big installations where space constraint and is not feasible, no, sir.
No, see, this is not, again, let me just frame this. Our solution is an envelope cooling
Okay.
primarily. Building envelope cooling is what we are focusing on. And I mean, I hope you're not confusing with the last installation. What we're doing is art installations as solution for houses. That's not
Right.
the, yeah. So our solution in general, what we're talking about, climate responsive building envelopes is what we are focusing on. Uh, like is the main solution that we are actually talking about to people. Yes.
Mhm. Yes. It's nice, sir. It's looking very aesthetically also looking very nice and very good one.
Thank
This
you.
one very good. I like this one, especially the last one you are what you showcase. It's very good, sir.
Thank
It's
you. Thank you.
where this cactus and other things what you are showcasing, no, sir. It's very nice one.
Thank you. Yeah,
Very good
we have
work.
a question.
I
Please
think
go ahead,
somebody
Prajna.
has raised their hand.
Yeah,
Yeah, yeah,
Raj, yeah,
please.
go ahead. Yes. Rajna, are you saying something?
Hear me?
Yeah, now I can hear.
Yeah, sorry. Yeah, I just wanted to say great presentation and great initiative. And I just had one question. Have you like recorded the temperature difference that your installation is giving? Like, what is the range that you have recorded so far in probably like some of the more hotter climates versus if there are installation in like, and what about in humid climates? So I just wanted to know your experience with that.
Yeah, we have recorded temperatures in different locations, different scales and stuff. So the average temperature drop, this is average, but because the performance of the system changes from season to season. In summers, we have even seen temperature drops going up to, like the temperature drop at the envelope going by 8 to 9 degrees. And in monsoons and stuff like, just not beyond at max, like, 2 to 3 degrees when it is extremely humid. So the average temperature drop we have seen cut off is annually 5 to 6 degrees. With the binary, we have done a lot of analysis. I also have one more presentation. I think after the Q&A, I'll just go through that as well, wherein I can explain about we have done a project with the at the army camp in Jaipur, and recently, and we started collecting data. I'll just explain about how we have installed the system there and what are the how it is behaving, and I'll try and answer with a lot of numbers in that presentation. Okay, just a few slides in that. I'll go through that.
Okay, great. I just want to know what is like, have you installed it in a humid location as well? Has there?
We have definitely done in a humid location as well. We have done one in Mumbai. Uh,
Okay.
the performance when of an evaporative cooler in direct, I mean, in humid locations is less compared to dry and hot and dry. But the way the system that we have designed is not and purely and entirely depending on evaporative cooling as a solution. So
Okay.
when I talk about this climate responsive building envelope as a solution, it is the behavior is manifold. First one, it acts as a direct shading device that cuts off the direct radiation into the buildings, whether it is hot or humid or any climatic zones. It acts as a first of all like a sunscreen that is cutting the direct radiation, and we are able to adjust and configure it according to the daylighting factor. So based on the amount of daylighting and everything that's coming in, the spacing and the density of these modules and everything are designed so that we can also do it according to the sun angle and the amount of daylighting that we need in. The third is the ventilation part, which we are talking about, not evaporative cooling, pure ventilation. So in all the projects that we do, we encourage our clients to reduce the air conditioning in at least majority of the spaces and go for natural ventilation with the help of a system like this, like a passive screen. And the fourth is actually the evaporative cooling part. So what's happening is that as a building envelope that is designed primarily for a specific location and climatic condition, it is targeted around not to just optimize on the evaporative cooling part of the solution, but also other aspects of passive design. And when you talk about evaporative cooling, the way we have installed solenoid valves and timers on the water system that depending on the humidity and the dryness in the atmosphere, the water trickles according to that requirement. So when it is extremely hot and dry, the amount of water that is trickled down is much more than compared to when it is when the temperatures are less and when it is humid. So that way we're able to optimize the water and also control the amount of water and the humidity in the atmosphere. So that's the work idea behind the work. Currently, we are doing the timers and everything manually, wherein we seasonally they have to feed it. But hoping that eventually we will reach where a point wherein this entire system can be automated is the idea.
Oh, okay, that's great. Yeah. Okay, thank you.
Yeah. Mr. Manikandan, hi. Please tell me. Are you saying something?
I think we can go ahead now. Nobody's speaking as I can see it.
Okay, I just thought there's a hand raised by Mr. Manikandan. So I'll just continue and then we can continue with the questions. Yeah.
Sure, sure. Yeah.
Okay. So there is another small presentation which is on a specific project that we have done in at the Army Cant in Jaipur, wherein the idea behind this, again, we use this as a solution, wherein we have proposed these walls on a window which are of height 12 feet by 8 feet, 8 of them on a space of 2,500 square feet. In this is what we have done. And the idea behind this work is this is installed in front of a window next to a corridor, so that this can actually help. And this is on the first floor. Let me show some images and I'll come back to this. So we have done this on the first floor completely here. And on the similar space below, what you see on the bottom floor, there is these are two rooms, one on the left and the right. Each occupies each of size 2,500 square feet area. So roughly about each space is taking 6 tons of air conditioners on the bottom. And on the top, we have replaced it with without air conditioners. We have installed these aerofoils on the facade and facing towards the southern side, keeping in mind the airflow and the sun and so on. So in this is exactly the setup where I was talking about, where we have used gravity as the means to put the water. And in the process, in the middle, we have installed a timer and a solenoid valve wherein we can regulate the water. And in this, like I said, in this, we are manually controlling the water based on the seasons, not automated. And eventually we will, the idea is to automate this. So the water gets trickled down and this acts as a screen that can like an evaporative cooling system. I mean, in short, I can say that this much more robust version of a cuss screen, or traditionally we have this bamboo mats and other stuff we're used to throw water. But this is an idea wherein we are wanting it to be part of the architecture itself, which is much more designed, it's robust, and with keeping in mind all the part of the building vocabulary, wherein we are able to get this cooling and everything inside with the help of that. There is also like, I mean, 1 second. So this is what we have finished. So in this, there is an average drop, what we had seen, 5 to 6 degrees drop is what we have seen in this particular project. So yeah, there are some other diagrams that are missing in this presentation, but that explains about this particular project. So any questions on this? I can take this one. And one more thing in this particular project is also that instead of all the tiles and everything, the terracotta that we have used is all discarded terracotta, wherein we have visited the brick industries and we have collected these second and third class tiles which are not fit for cladding or as a material. So we have actually gathered all of those, and because we are perfectly fine with material having cracks and what do you say, any kind of distortions, or if they're not perfect, because for us what matters is the porous nature of the material, but not just the geometry. And so anything with variation in thickness and stuff which are thrown in the industry, we have gathered all of that to make this installation. Yeah, so that's about that one. Any questions? Yeah, you are on mute if you are. Yes. Yes.
Yeah, sorry, during my previous time, my mic was not good in my laptop. Okay.
Okay.
So actually, the presentation was very nice, especially, most of the things are very natural thinking, basically. So very nice to see all these slides. So my major doubt is like the water which is going to get cooled, right? In the terracotta, that particular system. So that particular water is like recyclable, or like how many times we need to change and how it needs to be, controlled?
It is fully recyclable. And so what we're doing in spaces where we are providing this, So we are suggesting a provision where all the water can be collected, and with the help of a simple natural sand filter, and we give it back to the system, and the water can be recycled again. So the water doesn't get contaminated or anything because it's just direct evaporative cooling what we're doing, but it does collect. This also acts like a an air washer because it collects some dust particles or pollutants while it is pure, cleaning. So that water that goes into the system with this, and we have put sand filter in certain projects wherein, and from there it goes to the system back again. But it is the water doesn't go waste. We recycle it. Yeah.
Okay, okay. That's great. Okay. Second thing is like in the terracotta system, in some of the pictures which you have shown, especially in offices, where the entrance area is fully covered with that particular, module, small modules. So, but it will also cut the, the light intensity, right? So, like for example, in the morning, we need to switch on the lights
Yes.
always, right? Because the capacity of installation is more anyhow. Okay, so in that particular one area, one direction, for example, east or south or whichever area which we are putting it out, so that side light will not come inside, right?
Not exactly. So that's the best part about this is that you can design it according to the orientation, the daylighting, and all of it. And it's a very flexible system. The spacing changes according to the daylighting requirement. For instance, like there are certain areas where we have 6 inches spacing, or I'll just show you the slide, this GIF. In certain areas we have like where the angle and everything is optimized, keeping in mind how much amount of daylight or what we is also needed. So there are projects in which we are doing this. I mean, the spacing is totally in our hands. So from 6 inches to 8 inches to 12 inches, we are trying different spacing so that one can regulate the amount of daylight that's actually coming in. And but the angle at which we are positioning and also the styles, what really happens is that it cuts the direct solar gain and sends in diffuse light inside. So there is also like that. That's what happens with the system like this.
Okay. Okay, because why that particular question arises is generally whenever light passes, especially solar radiation comes where that we will get the heat intensity. So if we cover that particular area, then obviously the light part, it will not be there, right? So that's what that particular query came. Anyway, that's okay. And in vertical
No,
gain concept also,
you get ample amount of diffuse light through the system, and also the view and everything is also not interrupted. We are not blocking the complete the view of the setup for sure. And I not in this presentation, but I actually have some images from another project where we have taken some shots from inside of the ones which are actually built. So you can see that in that there is ample room for this, both the view and the light coming out. Yeah.
okay, sir, okay. And in vertical green concept, actually, the plants which you have mentioned that we can able to grow. It's like a bookshelf where in which we can able to put all the pellets, and the vertical green is coming up. So in that only small plants can be done, and it is suitable for all household, right?
It is definitely suitable for all households, but then the only thing what I have observed is that we need to go for water resilient plants in this. So we have tried different kind of plants, but because that helps in less maintenance. Because plants definitely wherever we are keeping, whether it is this or any other kind of vertical garden, needs maintenance. So as long as there is care for the plants, any of the plants and actually can work. And but that when we're putting plants, I think the care is the most important part. Like any other, I mean, garden that we do, one has to be take care of the plants. So yeah.
Okay.
I mean, there is no such thing as what kind of space or building. It is applicable in all areas. And there are areas where we also have done with this, just creepers in the bottom, and the creepers can grow on top. For instance, in the Jaipur project, we had done a hybrid of having this potted plants, and also in the bottom we had given creepers so that the creepers can also grow on this this network of this binary as well. So that's also we have done. Yeah.
Okay, but in this particular terracotta concept, like both the sides are open, right? Generally, wherever we are fixing that pellets, both the sides are open, right?
No,
Correct?
so in this case, like one has an option to, for instance, like it's like a second skin. So one can have an openable window or a corridor or anything in this. So we are doing an NGO project right now. So let me just show you that actually. Pranjal, is it possible for you to just share the link of the NGO if you have that? I'll just stop my share. I'll just pull one as we talk. I'll show you one project where we are doing this along the corridor and stuff. So it need not be that way. It totally depends on the, what do you say? Wait, I'll just show you this. Okay. I found one image of under construction. This is something that we are currently building for a school, actually an NGO. So if you notice this is a school with a lot of windows that are existing right now. And this NGO collects like, I mean, because this completely facing the south, they get a lot of heat and dry temperature into the spaces. So what we have done along the corridor, we have done this, and with some openings for the windows and stuff. This is still under, we are just building this. So all of this like provides that shading and also cooling for all the classrooms. And we have provided this exhaust on the other side. So that creates the air circulation and, and pulls the air through the whole setup. Okay, so there are no fans, but we have provided like for the inducing cross ventilation. So we are also using the aid of exhausts as well in this particular case. So yeah, this was something that we guys are doing now. Like this is how this is being also implemented. So the different areas we're trying it in different, we're testing out different configurations.
Okay. But if it is in both sides are open, is there any chance or possibility of entering, insects or something when after designing, after the, kind of completion of the job? Because in both
Actually,
sides, if it is.
Yeah. So think of it like a porous jali, and we have done it in our office as well. So what happens is that when the water is there, this is not like a system in which the dampness of the water stays within the system permanently. The material being porous, what happens is it eventually evaporates and it becomes dry when if you stop the water or something like that. So it's a direct evaporative cooler, but then when the system is not being, I mean, you don't have to run the water all throughout the day, and not like 24 hours. Definitely that's not the idea. So it works mostly like drip irrigation, and we're trickling the water down. And when you stop the water and all of that, and then the system is dry, and then it behaves like any other dry surface. It's not like it collects the mosquitoes or insects and stuff. But definitely in places, a lot of clients, I mean, who like where we are doing, not just because of this, in general, wherever even predominantly there's a mosquito problem, or even without the system what we're talking about, they are seeking solutions where having natural ventilation but mosquito nets and stuff for like, but that's more of a generic solution, not just because of the system that we are providing.
Okay, sir. Okay, sure. Thank you. Thanks a lot.
Any other questions? Just to give you a summary of the work, what we guys are doing, I would like to share a couple of results that we have gotten from the analysis that we had done so far. So there are two possibilities of how the systems can actually work and to what extent they can actually work. So in one of the projects where we had done run simulations and analysis in a residence project, what we had seen is that these systems are effective for up to 75 to 80% of the annual hours, average annual hours throughout the year. And the rest of the 20%, we still need to depend on some form of mechanical ventilation or cooling devices, because either the temperatures are extremely high or humid. So in those cases, probably this nature-based solution might not offer the 100% solution for that. So the efficacy of the system so far, what we had noticed is 80%. is what we have done. In a case where we are talking about buildings that are fully naturally ventilated, or where you're talking about hybrid systems or anything like that, to what extent we can get the efficiency. It is, yeah, so far it's not 100%. 80% efficiency is what we are noticing. And we had in a similar case wherein in a building where air conditioning is done, for instance, the office building, what we had done over there, what we had noticed is by installing systems like this, we were able to reduce the air conditioning load with proper shading and this daylighting. By cutting down the heat gain into the building, we were able to reduce the air conditioning load by about 26% in the project that we have done analysis. So that is the to the extent what we were able to get the reduce air conditioning load in buildings where there is air conditioning and you're only using the skin to not fully passively ventilate the building but reduce the load. So these are the two cases that we have noticed. And but yes, definitely not looking this as a 100% solution is yeah, is has been the case so far. Yes. Yeah. Hi, Shirish, and okay, yes.
Yeah, Chandrasekhar, if you want to go first, yeah, please.
Sorry, I'm interrupting. Sorry. Yeah. Okay. Sir, actually, as you mentioned here, whether this particular technique like terracotta and all those stuffs in the urban areas, like, cities,
Yes.
offices, in which we won't get that much natural, space or trees or maybe environment. So how it can be installed and how effective it will be there. For example, one office will be in the center and nearby there is one more office or maybe the buildings. So in that area, whether this is really achievable in that case, whether you have done something like that?
We are definitely see. I mean, we are trying to evaluate the setup for different locations and different configurations for that matter, and all the buildings that we are talking about are looking at configurations where in an urban setup where there are adjacent buildings casting shadows or like anything like that for the. I mean, never in isolation. So definitely from one space to another, and also during the time of the day, also the performance and everything change. But all in all, the idea behind is that how if you ask me exactly what is the performance, one has to evaluate that based on which location, which context, and which building that we are talking about, but not necessarily like we cannot generalize that. So, but yes, we have been testing it for different locations for sure and different configurations, and the performance varies if that's what you're asking. But the overall idea is to cut down on the dependency on air conditioners. The main point is that to see if these nature-based solutions can assist in reducing the dependency, but not to like at least I don't think what we are looking at here is 100% replacement for an air conditioner so far. Yeah.
Okay. So not 100% air conditioner, that is okay, but still whether after installation and maybe during that routine life or operation of that particular office or building, whether we had taken any kind of output like samples or maybe CFD modeling, something has been done like before.
Yes, we have been doing a lot of studies like that. Yes, CFD modeling analysis. We are also getting it lab tested to determine the individual performance, the systems, and all that. All of these things are being done right now. And especially if you ask me about office buildings and commercial centers, so we are also trying to see how pre-cooling with terracotta, because pre-cooling using other setups, there is a definitely there are certain challenges that one has faced, whether there is a pressure drop or of the air or the longevity of the maintenance of the system and all that in other industries where pre-cooling is used done using other mediums. But terracotta being robust and with a kind of like it also absorbs water within and retains the water and so on and so forth. So we're also testing it for in cases if not directly as an envelope, to cut the heat, can it be installed to reduce the cooling load by pre-cooling there that's going into the this cooling towers. So that what is it that we can gain by if majority of the work, because terracotta and has a beautiful what do you say resilience and like I mean the medium being very robust naturally. So we are also testing it where if it can do bulk of the work, and in the air that is actually entering into a cooling tower. So can it help in reducing the cooling load? So there in that case, it's not like direct envelope where we are using for cutting the heat and entering, but more of a pre-cooling system. So those things are also being investigated, and we are recording the data and trying to collect and see how we can generalize like stuff. But yes, that's all that stuff is part of the ongoing research. Yeah.
Thank you, sir. Thank you.
Yeah, so I have a very basic doubt. So it is regarding the maintenance of the system. So how often do we need to do that, and what is the procedure that we follow if we do some maintenance work? So let's say one of the elements of that system is broken. So is there a direct replacement, or I mean, what sort of maintenance we do with the systems?
In all the systems that I've shown you right now, we have engineered it in such a manner that it's easy to do maintenance, replace, and all of that. So there's a lot of product development that happened, wherein how we can replace the unit so that they're not interdependent and so on. So that kind of design stuff is done. Talking about maintenance and replacement, but as far
Mm-hmm.
as the material itself is concerned, unless you are constantly pouring water 24/7,
Mm-hmm.
the growth
Yeah.
of anything on the top is also unrealistic, even if you want to, because you need constant moisture for any kind of growth or moss to happen. So in fact, it's
Yeah.
more difficult to maintain, for instance, in humid and areas, coastal areas like in Kerala or Goa, you'll see this beautiful moss collected on the brick walls, but because the humidity and the moisture in the walls is consistently enough for it to cultivate. But that's not the case with urban cities, wherein you are using it like sparsely, and we're also
Mm-hmm.
using timers and regulators to control the amount of water flow that's entering. It's not like water is at surplus where you are running it on the system constantly. Okay, that's not the
Okay.
case.
Got it.
And it could have been what it is, like, inherently, unless somebody throws a brick at it or someone, like, damages
Mm-hmm.
it, strength of the material and the longevity of it is like pretty high. So other than external forces coming to it, we had seen that material by default, the life of it is, easily 15 to 20 years.
Okay, okay, good. And secondly, picking on to the Chandrasekhar's point, when we say that, so let's say we have a congested area like Nehru Place in Delhi. So how do you see this system getting like incorporated in that kind of area?
So like I said, I mean, at the moment, whatever work that we guys have been doing, we are checking in as, so our focus has been two areas, to be very,
Hmm.
like, but I cannot generalize it for definitely all scenarios for sure. Our
Yeah.
focus, yeah, has been on building envelopes that can reduce the heat gain and into the buildings and provide cooling, like shelter at the skin level. What is
Hmm.
the potential that we have? That has been the prime areas of focus, building envelope. And the second thing that we have recently started, it's very nascent stage about pre-cooling into, like, in the cooling towers. That's pretty
Okay.
much at the nascent stage. But there are definitely many other scenarios in which one can also look at how things work and how things don't work. But
Hmm.
like I said, our core focus has been limited to these two domains for the time being, like, cooling towers and
Okay,
these
got it.
envelopes.
Yeah. Mhm.
Yeah.
Yeah, with pre-cooling, so how much efficiency, or I mean, how much you would say the energy consumption has reduced when I mean, have you done some sort of basic calculations on that?
That is happening in terms of the calculation, but I can show you a couple of examples on this. Uh,
Hmm.
Pranjal, find the video that we're talking about. Are you there on the call? We had done for one of the cooling towers, and let me just check if yes. Okay, Pranjal, I don't have access to the presentation. You have to make it open to all. It says that I cannot look at that. And the other one is that if you can see if you can find the video of the Chandigarh project, I can just share that.
Yeah.
Okay.
In the meantime, Miss Nina has some questions.
Yes.
I mean, if you can take that, yeah.
Sure. Hello. Yes, yes. Please go ahead. Miss Nina, you are on mute if you're saying something.
Miss Nina, are we audible to you? You are on mute. You have to unmute yourself.
While she is looking into that, I'm just sharing this. I found the video that I'm talking about. So this
Yeah.
is something that we have done. There is also an audio in this.
सर टाइम हो रहा है 12:10 और ये जो AHU के लिए टेराकोटिंग सिस्टम बनाया है इसका जो एम्बिएंट टेम्परेचर इस टाइम शो कर रहा है यह है 33.9 और जो सेंसर जो इसके अंदर लगाया है फिल्टर के पास उसका आ रहा है 19.8 डिग्री और इसका सेंसर ये देखो सर अंदर लगा रखा है बिल्कुल अंदर बिल्कुल फिल्टर से चिपका के लगा रखा है और टेराकोटिंग यहाँ पे खत्म हो रही है इधर की तरफ
And this system, similar to this, was also done in other places as well. And I'll tell you something very interesting. This is done in Assam in a tea plantation factory, where like the surface temperature when it is rise 27.8 degrees, and when it is with water and the system that we have done, the surface temperature has gone down to 21.8 degrees in this case. And the other one which I had shown you in front of the AHU is probably an ideal case in peak summers, probably extremely favorable, I suppose, because that numbers are extremely positive, and I'm definitely cannot generalize because that seems like an extremely high performance in that particular case. But this is a nominal one wherein in Assam they have measured this. And one thing about common in both the projects that I have shown this is that these are systems that clients have done themselves as open source what we had done and then recorded the videos and sent it back to us. So and this is something that not done by us. There's another open source project wherein in a tea plantation that they have installed a system like this using the pod and locally, and they're trying to measure and then they keep sharing the stuff and data with us to see how things are working, and we just help them in guiding them in how to go about the system and certain nuances and so on. So yeah, like that has been the yeah, and there's another YouTuber who has actually made a YouTube video on this and posted it online and showing how the things are working. So anyways, I mean, I just wanted to show that AHU unit to about what's the performance in a pre-cooling system. Yeah. But that is something that we cannot generalize again throughout the year as well. Yes, subject to subject to humidity levels and wet bulb temperature mostly in the exteriors.
Miss Nina, if you want to go first, and then I'll call Miss Preeti after you.
You are on mute, Miss Nina, if you're hearing us.
Miss Nina has posted her question on the chat box. If you could please take a look.
Okay.
Yeah, sure.
It is terracotta, and we are commercially doing it. We have this the medium of terracotta, which is also white in color, like beige stone also is something that we managed to get, because many times people are not just happy with just having one color as an option with this red. So we have experiment few colors, but yes, currently we have beige and red as the color, and it's also terracotta. Yes, and it is commercially, yes, recently we started commercially doing it in few places. So yeah. So yeah, we are doing projects commercially at the time. It's available.
Miss Preeti, if you have still have your question with you, I see your hand put down. Yeah, please
Actually,
go
I
on.
wanted to know the costing part of it. How much does it cost?
So currently this envelope cooling systems are somewhere like from 800 to 1200, depends on the density, location, structure, what the height and all of it. That's a per square foot cost that we are getting right now, somewhere between 8 to 1200 or something like that. But it's entirely subjected to the location area and all that. And that too, but probably hoping that going forward, this could actually come down with the scale. So we are doing currently as a startup with small batches, but going forward, I think those costs could actually come down pretty much. Yeah.
Have you done the cost analysis of it?
Yeah, we have done the cost analysis of it. What in our particular case, what's happening is that since we are talking about as a facade system, like instead of using any other system, we are actually proposing something that is climate responsive or something. So the incremental cost in using something like this against a regular system is only about 150 to 200 rupees per square feet. Because if not this, people would use any other cooling system or a facade system for their projects, right? So by using this, in fact, like I said, in our particular case, it's only the incremental cost that is we are looking at. And the ROI for especially for the Jaipur project with 6 tons AC and what we have done so far with for like this particular system is roughly about 2 years is the ROI.
Okay, thank you.
Yeah.
Mr. Deepak, if can you unmute?
Yes,
Yeah,
yes,
please,
yes.
please go on.
So the frame in which you put all these, is it like, will it corrode or rust formation will happen?
No, actually, in all the frames that we have done, we have managed to optimize the amount of steel and also galvanized it with 700 GSM of zinc, this thing, galvanization. So this is keeping in mind that, all this thing, the corrosion and this. So that is taken care of. And in the aerofoils, we also have an option of instead of using this galvanized steel, we can also go for aluminum extrusions as well that will make it any kind of this thing corrosion or anything with water not this thing. We took care of that in the product. Yes. Yes, Mr. Chandrasekharan. Yeah.
One more small doubt, sir. Like, these particular, your experiments and also the projects, whether, outside Indian climate, did you check somewhere? Like, for example, in
Yes,
Gulf or maybe totally in a different area like Canada or something like that? Or Europe?
Installations in Mexico are done wherein we have guided them in the process and they have done it themselves over there. They shared the images. So we have done it as an open source project with them. We shared the information. They did it. And in the Middle East, especially in Saudi, we have like proposed one of the architects. We are collaborating with an architecture firm over there, wherein they have pitched it to clients using the system over there. And we have also had certain inquiries from the Middle East, especially wherein they're interested in doing it, but like there's still conversations in process. So in Mexico, they have implemented that, but in the Middle East, we are still on in conversations. Yes.
Okay. Because maybe in these two different scenarios, whether how far it's performing and do you have the results or something like that? That's what my query. Okay.
No, in the Middle East, I think we have tremendous potential for this product to perform because, like I said, it's not just an evaporative cooler. These are actually climate responsive envelopes that can cut the heat and a lot of factors that are actually gone into the designing of this. So we see a huge potential in the Middle East for sure, and even in Mexico hot and this dry climates. But yeah, we are still, I think, evolving as a studio, and we are trying to see like hopefully, I think going forward, we'll get more opportunities to try out and get more data.
Okay. Perfect. Thank you so much.
Before closing, if we have any other questions, I mean, we can take one or two if there is. Okay, so I don't see any other questions coming up right now. So I'll just wind up by thanking all the participants to be there and to Mr. Monish. Thanks for this wonderful and insightful presentation. And if you have any further questions to all the participants, if you have questions, please post us on our email ID, which is in the chat box. I think Dinu will paste it right now. And you can please share your questions or doubts, and we will direct it to Mr. Manish, and he will definitely provide you with some uh, clarifications. Also, if your organization would like to join the business charter as a signatory, please express your interest by sending by sending a short email to the mentioned email ID that has been shared in the chat box. And yeah, I think this is good to go. Thank you everybody for joining. Let's
Thank
call it a
you.
day.
Thank you
Yeah.
everyone for joining this. And please definitely share any kind of questions, comments, suggestions, feedback that will help us in our research, what we're doing. So we are also trying to actually do it in as many places and collect data. So any kind of suggestions or inputs will be really valuable. And do feel free to ask us any kind of, any kind of questions actually that will really help us in pushing this even, better. So thank you so much. Thank you for this opportunity.
Can we get the presentation? Yeah. Can we get the presentation and your details if possible?
Yeah, I will. Thank you. I'll do that. I'll share the presentation. Yeah. Thank you, everyone.
Sure. Thank you.
Okay. Thank you. Thank you, everyone. Bye bye.